In this lesson, we will explore identities related to sum, difference, and products of sines and cosines. Let's get started with the first one. And we are going to find out sum of sine and sine. So if we take a look on this formula, sine alpha plus beta, that is equal to sine alpha cos beta plus cos alpha sine beta. Let's call this as 1, and also we know that sine of alpha minus beta is equal to sine alpha cos beta minus cos alpha sine beta. Let's call this as number 2. By adding 1 and 2, adding 1 and 2, what we have on left side is sine of alpha plus beta plus sine of alpha minus beta. Alpha minus beta, the last of both 1 and 2 will get cancelled, leaving behind 2 sine alpha cos beta, because this would cos alpha sine beta will cancel out with minus cos alpha sine beta. So this means we have an identity 2 sine alpha cos beta equal to sine alpha plus beta plus sine alpha minus beta. On the left hand side we have product of sine and cos. On the right hand side we have sum. This formula can be used to convert product of sine and cosine into sum of sine and sine. Similarly, we can prove that we can prove the other identities, which are 2 cos alpha sine beta, 2 cos alpha sine beta equal to sine of alpha plus beta minus sine of alpha minus beta. This can be obtained if we were to subtract 2 from 1. And similarly, if we were to use cos alpha plus beta and cos alpha minus beta, we would have got 2 cos alpha cos beta equal to cos alpha plus beta plus cos alpha minus beta plus cos alpha minus beta. And the last one in this regard is minus 2 sine alpha sine beta equal to cos alpha plus beta minus cos alpha minus beta. So these identities, let's say we name them as A, as B, as C, and as D. These identities A, B, C, and D are used for converting product of sines and cosines to sum of sines and cosines. While if we want to convert sums into product, we can choose alpha plus beta for converting sum to product. Let's assume that alpha plus beta is equal to P. that alpha plus beta is equal to P and alpha minus beta is equal to Q. Then this means alpha will be equal to, by adding 2 alpha will be equal to 2 alpha is equal to P plus Q and alpha is equal to P plus Q by 2. And if we have alpha minus beta, subtracting we have 2 beta equal to P minus Q, means beta is equal to P minus Q divided by 2. So now we can have, with these values of alpha and beta, with these values of alpha and beta, we can have sine P plus Q, sine P plus sine Q equal to 2 sine P plus Q by 2, 2 sine P plus Q by 2 into cos P minus Q by 2. This is similarly as adding sine of alpha plus beta plus sine of alpha minus beta. It's just in the reverse order. Sine of P minus sine Q minus sine Q is equal to cos of 2 cos of P plus Q by 2 into sine of P minus Q by 2. And this would be cos of P plus cos of Q. Cos of Q would be equal to 2 cos P plus Q by 2 into cos of P minus Q by 2. And cos of P minus cos of Q, cos of P minus cos of Q, that would be equal to minus 2 sine P plus Q by 2, P plus Q by 2 into sine of P minus Q by 2. So these are the identities which can be used when we convert from sum to product. The first one, A, B, C and D, are used when we want to convert from product to sum. Let's get started with the first example. And the first example is, let's simplify the first question. Here is, express 2 sine 7 theta into cos theta as sum or the difference. So we are given 2 sine 7 theta cos theta. Given is 2 sine 7 theta into cos theta. This clearly is the case of product to sum. So this will be equal to sine of alpha plus beta plus sine of alpha minus beta. Whenever the sine is first and the cos is second, this is case of sine alpha plus beta plus sine of alpha minus beta. So this will be equal to sine of 7 theta plus theta plus sine of 7 theta minus theta. So this is equal to sine of 8 theta plus sine of 6 theta. This is how we can convert from product to sum. Remember, the identities A, B, C, and D are used for converting product to sum. And when there are the sine and cos are both present in the product, we use the formula for sine alpha plus beta and sine alpha minus beta. If both are sine on left side or both are cos, we use the cos. So let's take a look on the next question, in which we are required to prove without using the table sine 19 cos 11 plus sine 71 and sine 11 degree equal to 1 by 2. So let's get started with this one. Example. Given expression on the left hand side is equal to sine of 19 degree and cos 11 degree. Sine of 19 degree into cos 11 degree plus sine 71 and sine 11 plus sine 71 and sine 11. This is, yes, and now we are going to multiply and divide it with 2. So in the next step, we are going to multiply and divide it with 2, so that this is 2 sine of 19 degrees cos of 11 degrees plus 2 sine of 71 degrees into sine of 11 degrees. And if we write 1 by 2, the 2 is dividing outside, then we can have it as, this is sine times cos. So this is case of the first A, in which we write sine of 19 plus 11 plus sine of 19 minus 11. And because there is a negative in the formula for sine times sine, so we keep that minus outside, and we will be using cos of alpha plus beta minus cos of alpha minus beta. So this will be equal to cos of 71 plus 11 degree into, then this will be minus cos of 71 minus 11. Cos of 71 minus 11. And this is the step. Now we divide 2 outside, and let's take a look on the sine 19 plus 11 degree is sine of 30 degree. So this is sine of 30 degrees plus sine of 19 minus 11, that would be equal to 8. So this would be equal to plus sine of 8 degrees. And because of this negative sign outside, we will have minus cos of 71 plus 11, that would be 82 degrees. And negative time negative will become plus. This will become cos of 60 degrees. And now if we substitute the value of sine 30 is equal to 1 by 2 So this is 1 by 2 plus sine 8 degrees minus cos 82 degree can be written as 90 minus 8 degrees plus 1 by 2. That is value of cos 60 degree. So this is equal to 1 by 2 into 1 by 2 plus 1 by 2, that is 1, plus sine of 8 degrees minus sine of 8 degrees, because at 90 degree cos is going to change the ratio from cosine to sine. So this will get cancelled and we will have 1 by 2 times 1 equal to 1 by 2. And this is what we were required to prove, which is required to prove. And now the next question is that we are going to prove cos A plus cos 3A plus cos 5A plus cos 7A. We are going to express this sum as product. So let's do this. Given expression, given sum is cos of A plus cos of 3A plus cos of 3A plus cos of 7A plus cos of 5A plus cos of 7A. So now let's apply the sum to product formula on the first two separately and on the last two separately. So let's apply this on the first two, cos P plus cos Q, and by using that formula this will be equal to 2 cos of 3A plus A by 2 into cos of 3A minus A by 2. This is the formula for cos P plus cos Q. And similarly, if we apply the same formula on the last two, we will have 2 cos of 5A plus 7A by 2 into cos of 7A minus 5A by 2. It doesn't make a difference if you take 5A minus 7A, because cos is an even function and it's still going to become positive. But this is equal to 2 cos of 2A, because 3A plus A will become 4A and 4A divided by 2 will become 2A into cos of A plus 2 cos of 5A plus 7A will become 12A. So this will become in total 6A into cos of A. And now we can take 2 cos of A common, 2 cos of A outside, and what we will have inside is cos 2A plus cos 6A. And we can apply the same formula again, and this time if we rearrange it a little bit, so we have cos 6A plus cos 2A, so that 2 cos A into 2 cos of 6A plus 2A by 2 into cos of 6A minus 2A by 2. And this will be equal to 2 cos of A into 2 cos of 4a time cos of 2a. And we have this in the form of 4 cos of a cos of 2a into cos of 4a. That is the required product, and we'll see you in next lesson.